I am going to do two of the problems on the extra review. One of them I believe is number 3, and it's f of x equals x to the 4th minus 14x squared plus 45. And I wrote 42. 45. Here's a sketch of the graph. I'll use that in a second. But for now, I want to go ahead and factor this like I would a quadratic. So if I do that and I have x to the 4th, x squared, and a constant, I can simplify this into x squared and x squared. And then I'm looking for what multiplies to 45 and adds to negative 14. And if I think about 45, I have 1 and 45, 3 and 15. Oh, but then I have 9 and 5. And if they're both negative, then I'll get a negative 14 when I add and a positive 45 when I multiply. So I keep breaking this down because I can break down x squared minus 9 into x plus 3, x minus 3. This one I can't split, so that would be factored as much as it can be. But then my zeros over here are going to be negative 3, 3. This I kind of have to do a little work if I'm not good at that. And I'll say x squared equals 5. Remember, we're setting everything equal to 0 always. So I have plus or minus the square root of 5. And I don't need an I because when I took the square root, there wasn't a negative. So here's the process of factoring that. So this red will say is factoring. And then what we'll do in blue is what will happen is if we use the graph. And this one here, like if I had to find the rational roots, which I didn't do, I'd have to have all the factors of 45 over all the factors of 1. And that would have included actually the 3 over 1, which is right there. So there's some of the rational zeros. If I use the graph, you can see that I graphed it here. And I have two zeros that are nice numbers, negative 3 and 3. So if I go ahead and use negative 3 in the synthetic division, I have to put in a bunch of blank spaces for all the pieces that are missing. But when I go through, I have negative 3, multiplied together give me 9. I have a negative 5, positive 15, and then when I multiply negative 45, and I get a 0, which I should have done because negative 3 is a 0, x plus 3 is a factor. And now we have third degree, and so I'm going to use these here. This one now went from a 4th to a 3rd, but we need a square in order to do the quadratic formula. So now I need to keep dropping down, and I'll use the other 0 because I had a negative 3 and a 3. So I use the other 0, 3, 0. When I multiply 0, negative 5. When I multiply negative 15. I should always kind of be like one spot over. So now this is a 2nd degree. So I could use the quadratic formula if I like, but I know I have x squared. I don't have any x's. Minus 5 equals 0. So if I wanted to go ahead and solve from here, I'd have x squared equals 5. X equals plus or minus the square root of 5. So my zeros are negative 3. We have to include the ones that we found in the calculator, and plus or minus square root of 5. So here's two options to finding the zeros, either by factoring or in the calculator. We should know both depending upon what I ask you. The other problem is, I forget which number it is now from the review, but it's number something. It's f of x equals 2x cubed plus 4x squared minus 5x minus 10. This right here we'll do with factoring first. And I'll do that factoring with grouping because there's 4 terms. And when I do that, I'll take out the greatest common factor here, which is 2x squared. And then I'll be left with x plus 2. And now another x plus 2, so I'll have to take out a negative 5. And then I'll get an x plus 2. So x plus 2 is my common factor, and I'm left with 2x squared minus 5. And now I have my zeros being x equals negative 2. If I set this equal to 0, 2x squared minus 5x equals 0, 2x squared equals 5, x squared equals 5 over 2, and then x would be equal to plus or minus the square root of 5 over 2, which I have to simplify because I can't have the radical like with a fraction. So if that's the case, I'll get the square root of 10 all over 2 because I'll be multiplying each by the square root of 2 like that to get there. So these are my other zeros. Now if I was to go ahead and use the calculator to factor, I would have had to gone through, and I see this 0 was 1.5, that was negative 1.5, and that one was 2, negative 2. So negative 2 is the one that works. So if I use the graph and then I use synthetic division, I have to use my negative 2 and then the original problem. So 2, 4, negative 5, negative 10. So 2 times negative 2, negative 4, 0, 0. Negative 5, coming back around, I get positive 10. All right, so here is good enough for the quadratic formula. Or you could just go ahead and solve using square roots. If we wanted to use the quadratic formula, we'd have negative b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and reducing that. Well, b is 0, so I can write that. 0 plus or minus b squared, well, that's 0. Minus 4 times 2 times negative 5 all over 4. My music's playing. I don't know how to get rid of that now. There we go. If we go a little further, 0 plus or minus, here's where a lot of people mess up. You have a negative 4 and a negative 5, so it's going to end up being positive. So I'm going to have, well, negative 8 times negative 5 is 40. That's going to be over 4. So I'm going to get rid of the 0 since I don't need it anymore. So plus or minus, breaking up the 40 is like the square root of 4 times 10. So I'll be taking the square root of 4 out. And here's where I can reduce these. So I'll have x equals plus or minus square root of 10 over 2, which is what I got before. So that my final zeros are negative 2 plus or minus square root of 10 all over 2. So here's my zeros for that as well. If I did have something down here, and I did have a b, I would have had to reduce everything in the numerator and then go ahead and I would have to simplify it to both of these. Since there was nothing here, I don't have to worry about it. The only time you can actually reduce is when you have something here in the b spot and something out here with the denominator.